Okay, today we are looking at a practice question on conservation of mechanical energy and work. So what we have here is a ski slope, and we have a skier that's going to start at the top. His mass is 65 kilograms. He's going to start at the top of the hill, and there's going to be basically no friction, negligible friction between his skis and the slope. He's waxed them up really well, uh, all the way down the packed snow until he reaches this unpacked snow where there's going to be more friction. And he's going to come to a stop after 25 meters. So there are a couple things we could figure out. We could figure out his amount of potential energy in the beginning, how fast he's going when he reaches this 14-meter high hill, and how fast he's going at the bottom of the hill. We can also figure out how much friction there is between his skis and the unpacked snow. So let's go ahead and do that. First, before we do anything else, we need to figure out how much energy he's starting with. And we know it's the energy of height, which is potential energy, mgh. So the potential energy will be his mass, which is 65, times gravity, which is 10, you can use 9.8 if you like, times height, which is 62 meters. Now, if we multiply all that together, excuse me, we get a potential energy of 40,300 joules. Much better, much better. All right. Now, we know that that's the amount of energy, that's the total mechanical energy in the beginning. So that will be the same mechanical energy the whole time until we have some outside force act on the skier, which is friction. So all the way down the packed snow, he'll have the same amount of mechanical energy. So let's go ahead and notate that. The mechanical energy is 40,300 joules. So now we can say mechanical energy is equal to potential energy plus kinetic energy. We can then figure out our potential energy at the 14-meter high hill, and we can use that to figure out the amount of kinetic energy, which we can then use to figure out the velocity. So let's do that. On the 14-meter high hill, we know the mechanical energy is 40,300. The potential energy there would be mgh, and the kinetic energy would be 1/2 mv squared. So 40,300 is our mechanical energy again. The mass of the man is still 65, gravity is still 10, and the height here is 14 meters. The kinetic energy is 1/2, his mass is 65, times v squared. Now we only have one variable, and thus we can solve for it. So let's do it bit by bit. 40,300 equals 65 times 10 times 14, which will give us 9,100, plus, now 1/2 of 65 is 32.5 v squared, and you can't really see that. Let me scroll down so you can see what I'm doing. And now we'll subtract the 9,100 from the 40,000. That will give us 30,900 equals 32.5 v squared. We'll divide both sides by 32.5. That will give us 950.8 equals v squared. And finally, we'll do this, get the square root of both sides to get our v alone, which will give us 30.8 equals v. And that'll be in meters per second. Excuse me. There we go. Okay, so we figured out how fast the dude was going at the 14-meter high hill by saying he started with a certain amount of mechanical energy, 40,300 joules. That mechanical energy was equal to the sum of all the potential and kinetic energy he has. So we just plugged in to this, mechanical energy equals potential plus kinetic. All the meanings, right? Mechanical energy, potential energy is mgh, kinetic energy is 1/2 mv squared, and then we just plugged in and solved for v. All right, now we want to know how fast was he moving at the bottom of the hill. Now, what we know is all of that mechanical energy will equal kinetic energy here because the potential energy is 0. We could even do this and then we could just plug in mechanical energy was 40,300 equals kinetic energy plus 0 because we know the potential energy is 0. I'm going to go ahead and replace this this kinetic energy with 1/2 mv squared. And so 40,300 equals 1/2 times the mass of 65 times v squared. So that would be 80,600. Multiply both sides by 2 to get rid of that 1/2. 65v squared. Divide both sides by 65. We get 1240. Getting off the screen. 1240 equals v squared. And finally, we'll get the square root of both sides to give us 35.2 meters per second at the bottom of the hill. Again, what we said was because it's at ground level now, all the potential energy is turned to kinetic energy. All the mechanical energy is kinetic energy. So we just set our kinetic energy to 40,300 and use that to solve for velocity. Okay, final question is if he comes to a stop in 25 meters, how much friction was there? How much friction was there? So I'm going to go back and do some cleanup here. Leave it with a mechanical energy of 40,300 joules and make some room. Okay, now what we know is all of that kinetic energy was lost to work as he goes across that rough snow because he comes to a stop. So what we can say is the change in, that's not what I wanted to paste. That is the announcement for today. The change in the mechanical energy will be the amount of work done. So we can say the loss of 40,300 joules will equal the work. So negative 40,300, excuse me, not 3,000, equals force times distance, and negative 40,300 equals force times 25, since that's our distance. We'll divide 40,300 by 25, and we get 1,612 newtons as our force. Negative, of course, because it is slowing him down. Hopefully that helps you. If you have any questions, make sure you send me a message or an email.